Hello, good evening. So in this session, we will see some questions on ellipse. Look at the first question. So P and Q are 2 points on the ellipse, and y1 is given to be positive and y2 is given to be positive. So that means we just have to select the coordinates in the upper half plane. Okay, that means above y-axis. So above x-axis. Let's see denote the circle and end with the point 3, 0. All right, so just let me plot the diagram. So it looks this way a bit. Um, so it's like this. So now if I consider here, then I have an ellipse here. This is the ellipse right here, denoted by, there is a notation, no, there's C denotes the circle. So this is my circle here. The radius is 3, 0, of course, because we have circle x square plus y square is equal to 9, and ellipse is x square over 9 plus y square over 4 is equal to 1. So this is my point M, which is 3, 0. Now what they have given, suppose the line x is equal to x1 intersects C at R. So there is some line x is equal to x1. We can just draw it here somewhere. This is my line x is equal to x1, and the line, this intersects C at R, and then x is equal to x2. So there are basically two lines, and they are intersecting the circle and ellipse both, such that the y coordinate of R and S are positive. That means we have to take it on the upper half plane. And angle ROM is pi over 6. So R over M. So R is point on circle. So this is my point R, and this is O. So basically we mean this. So angle ROM, this entire thing. So that means this angle is 30 degree. And then we have angle SOM. So this intersects x2. So this is my line x1. This is my line x2. So x is equal to x1, line intersects the circle at R. So this is the diagram, and line x is equal to x2 intersect a circle at S. So I have here this point being S, and this is my line x2. And then what they have given is SOM. So if I just draw this one, so I have SOM to be 60 degree. So this angle right here is 60. Now what do we need? Yeah. So now let xy denote the length of the line segment xy, then which of the following statement is true. So we want the equation of the line joining P and Q. So P is basically, we have P, what's the position of P here? Okay, P and Q are two distinct points on the ellipse. That means this is my point P and Q. So it could be any one of them. Or else, wait a moment, did they mention anything? No, P and Q are two distinct points in the ellipse. Just suppose C intersects at S and the points of R is not positive. No, there is no mention. So that means now we can go ahead. We can take this point to be P, and we can take this point to be Q. So basically they want the equation of the line joining P and Q, so it does not matter where are P and Q. So we just want two distinct points on the ellipse. So the only thing that we have is this. So let's go ahead. Now, if I go ahead, then the first task would be to find out these coordinates. So point S would be what? Radius is 3, so I'm going to have here 3 cos theta, comma 3 sin theta. And since my point, my theta is for the circle S, for this point, SOM, that is 60 degrees. So I'll be having here 3 cos 60, comma 3 sin 60. That means I'm now going to have S to be what? 3 cos 60 is half, so 3 over 2. And 3 sin 60 is 3 root 3 over 2. That means this is my point S. And then I also have to find out R. So point R is going to be, point R is out on the circle. Again, but angle here is different. So again, 3 cos 30 I'll take, and then 3 sin 30 I'll take. So this is going to give me 3 cos 30 means 3 root 3 over 2. And 3 sin 30 means 3 over 2. So we got both the points. Now, so once I got S, that means I got here my point, x2 also here. And R I have here. So R point I got. Now I know the coordinates of P basically. So the coordinates of P are going to be what? Because we anyway want the equation of line joining P and Q. So we need the points P and Q. So for point P and Q, so for points P and Q, we can assume P to be say since point P is lying on the ellipse, that means any point on the ellipse will look like this: 3 cos theta, comma 2 sin theta. Now, so if you watch here carefully here, then it's basically angle ROM, and we ellipse get its coordinates from its auxiliary circle. So this circle, the given circle, is serving as the auxiliary circle. That means we can use the eccentric angles of my auxiliary circle. So I'm going to have angle R is making 30 degrees. So I'm going to use the same coordinates. So P is going to give me 3 cos 30, comma 2 sin 30. So this will give me 3 root 3 by 2, and sin 30 is half, so I get only 1. So this is my point P. And Q we can assume to be again uh, 3 cos some other angle phi and 2 sin some other angle phi. Now angle point Q, the eccentric angles, if I find out for Q, then it's basically uh, lying in S only. So the auxiliary circle would give the parametric points here. So for Q, it's making angle 60. So I'm going to use 60. So this will give me 3 cos 60, comma 2 sin 60. So I'm going to get Q as what? 3 times, and then cos 60 is half, and 2, and then root 3 by 2. So this gets cancelled. So Q I'm going to get is what? 3 over 2, and then root 3. Now P and Q coordinates we have got. What else is required? The equation of the line joining P and Q. So of course we can get the line joining P and Q points. So y minus y1 is equal to, now let's find the slope. So y2 minus y1 upon x2 minus x1, and then x minus x1. That's what we get. We can simplify this further. So this gives me, this is root 3 minus 2. So root 3 minus 1 into 2 over, from here we can take root 3 common. So I'm going to get here, this is root 3 minus 3 into x minus 3 root 3 by 2. Now the further simplification, is it required? So 2x plus 3y, yes, it's required basically. So let's check what it gives me. This right here I can take common. So I'm going to have basically y minus 1 is equal to, this is, in fact, from here we can take one more root 3 common, and this gets cancelled. So I can write down here y minus 1 is equal to minus 2, and this is root 3 minus 1. And here we can take one more 3 outside. So root 3 into root 3 will be 3. And then I get here root 3 minus 1 into x minus 3 root 3 by 2. So this entire part gets cancelled. So that means basically I'm getting is, what I'm getting is y minus 1 is equal to minus 2 by 3. So minus 2 by 3 into x minus, what's the point for x? 3 root 3 by 2. 3 root 3 by 2. So I can just multiply or take the LCM, whatever I want. So take the LCM better. So this LCM here is 6. So I'll write down here 6y minus 6 is equal to minus 2 times. This will be 2x minus 3 root 3. So I can just take this here, or else we can cancel here. So 3y minus 3 is equal to minus of 2x minus 3 root 3. So this will give me 2x plus 3y is equal to 3 plus 3 root 3. So this makes 3 plus root 3 is basically 3 plus 3 root 3. Yes, that means this makes my option A correct first. That means B is wrong, because that gives me 2x plus y, which is incorrect. Now we need to have here n2 is x2 comma 0. That means this is n2 is x2 comma 0. So x2 comma 0 is this point basically. That means this is my n2. So it is x2 comma 0. That means n coordinates I know. So n coordinates are nothing but if we just extend it further. So x2 point n will be nothing but, see this point S I know. Point S is what? 3 by 2 comma 3 root 3 by 2. That means S2 is 3 by 2 comma 0 is n. That's my n2. N2 is x2 comma 0. So x2 we found. That is just the projection here. I can take it. So that's 3 by 2 comma 0. And then Q. Q is basically, it's on the same line. So Q is basically here. I've taken Q is 3 by 2 comma root 3. So 3 by 2 comma root 3 is my Q. And then S point I already have is 3 by 2 comma 3 root 3 by 2. Now what do they want? Is N2Q. So that means I want N2Q distance. So N2Q distance and N2S distance. So I know it's just a matter of heights. That means we need to find the distance. So here, if I consider this 3 by 2 and then I go just root 3 units above. So I get my N2Q. So N2Q distance is basically root 3 and N2S distance is nothing but 3 root 3 by 2. So that means um, I can take 2 here. So I get 2 N2S is equal to now 3 root 3. So 3 times will be here only, and root 3 is nothing but N2Q. So that actually makes my option C also correct because N2 is actually 0. So now let's go for the option D. Option D is what? N1 is equal to x1 comma 0. So x1 is my point N1. So N1 is x1 comma 0. That means my point N is x1. X1 is nothing but R, projection of R here on the x-axis. So R is 3 root 3 by 2. That means this is going to be 3 root 3 by 2 comma 0. So this is my N1. And next is P is required. P already I have. So P is simply 3 root 3 by 2 comma 1. So P is 3 root 3 by 2 comma 1. So this is my point P. And then what is required? R also required. R is point on the circle. So R is 3 root 3 by 2 comma 3 by 2. So R is 3 root 3 by 2 comma 3 by 2. So this is R here. This is R here. Yeah. So now what do we need basically? Is N1P. So N1P is nothing but one distance. So N1P is simply just 1 because from here if I just move 1 unit above in the y-axis I get my distance 1 is N1P and then N1R. So N1R if we see then N1R would be 3 by 2 and then I get to see here 9 times N1P. So 9 times N1P would give me 9 and 4 times N1R would give me 4 times N1R would give me 6. So yes, they are not equal, but they are saying that these two are equal. So option D would be correct. That means correct answer is A and C. Moving to the next part. So here we are given T1 and T2 be two distinct common tangents to the ellipse, and there is a parabola y is equal to 12x. So let us draw the parabola and the ellipse. So it would look like this somewhat. Now let's try to draw a diagram. So now they are saying this is my point 6. That means this is going to be root 6. And this point is root 3, where this is intersected, y-axis. The parabola y square is equal to 12x. So I have my parabola. The blue one is my parabola. Y square is equal to 12x. Now, suppose the tangent T1 touches P and E at points A1 and A2. So we can see here there is some tangent here. It touches ellipse and parabola. So the diagram would go somewhat like this. Yep. No. It touches the parabola at touches T1. This is my tangent T1 basically. I'll take this is my tangent T2. So tangent T1 touches parabola at point A1 and A2. So this is my point parabola at A1 and ellipse at A2. And then tangent T2 touches parabola at A4. So this is my point A4 and this is point A3. Now what is required mostly in this question? Area of quadrilaterals. So that means if I just draw this quadrilateral, so these are basically the point of chord of contact. So I want to find out the area of this quadrilateral A3, A4, A1, and A2. So I want to find out the area of this quadrilateral. So now for this thing, okay, we can first find out this point of intersection. Let us see the nature. So we have y is equal to mx plus a by m is tangent to the parabola. Is tangent to the parabola. So if this is my tangent to the parabola and here 4a is equal to 12, so this implies a is equal to 3. So when a is equal to 3, I have y is equal to mx plus 3 by m. This is the tangent. And now since this is also tangent to the ellipse. This is also the tangent to the ellipse. This is also the tangent to the ellipse, which means I'll be having c square is equal to a square m square plus b square. So the condition of tangency for ellipse. That means c square is, I have here is 9 over m. So I'll be writing here 9 over m. 9 over m is equal to, the point here is a square m square. So a square is 6. So that means I get here 6m square plus b square is 3. So we need to solve this equation. That means I can cancel this by 3. So I'm going to have 3 over m is equal to 2m square plus 1. So I have this. And now if you watch it carefully, so we have here 3 is equal to 2m square plus 1 into m. So if you watch it carefully, then m is equal to plus minus 1 because 2 plus 1 will give me 3 and here for 1 minus 1. So m is equal to 1 and minus 1 will satisfy this equation. N is equal to 1 will satisfy, n is equal to minus 1 is not satisfying. It seems. No, but this is c square, so this is going to be basically m square only. So yes, now it will satisfy. So m is equal to plus 1 and minus 1. So these two will satisfy. So that means equation of tangents is y is equal to mx plus 3. So m is 1. That means I'm going to have here x plus 3. So y is equal to x plus 3. Wait, that part is also not required because since we have m is equal to plus minus 1, so this implies the product of slopes is minus 1. So the product of slopes is minus 1. This implies tangents are T1 is perpendicular to T2. So if T1 is perpendicular to T2, that means we know that these two are perpendicular tangents to the parabola. So they must be drawn from the directrix. So they will intersect on the directrix. So y is equal to x plus 3, and then second would be y is equal to definitely minus x, and here we have minus m. So yeah, yx minus 3. So that means they're intersecting at minus 3 comma 0 only. So they intersect at minus 3 comma 0. So they're intersecting at minus 3 comma 0. So they're intersecting here at minus 3 comma 0. That means now what do we want? We want the area of this quadrilateral, which I'm highlighting now with yellow. So to get the area of this quadrilateral in yellow, what are we going to do is we will find out the area highlighted by the green. So that means I'll find out the area of this triangle. I'm going to find out the area of this green triangle, and then from this we will subtract this area. So I get the quadrilateral. So this area we can get it directly. So area of triangle, let's say this is point, they are intersecting at point, the point is not given. So let's take this R. So suppose this is my point R, they intersect at R point. Now I'll find the area of triangle. This one is A1, A4, and R. So A1, A4, R. A1, A4, R. This would give me S1 to the power 3 by 2 over 2A. This already we have derived the result in parabola section, the area of the triangle found by the chord of contact and the point. So S1 is minus 3 comma 0. So minus, we have here y square minus 12x. So this is minus 3 comma 0. So I get here 0 square minus 12 into x1 is minus 3. So this gives me 36 to the power 3 over 2 by 2 into A is 3 here. So let's plug in A is equal to 3. So this gives me 6 root 6 by 6. So I get here root 6 basically here. So to the power 3 by 2 is going to be, yes. So minus 3 comma 0, then y square is 2x. So we just have plugging so it's power 3 over 2 over 2a. Oh, sorry, this is 36 basically, not 6. 36 root 6. 36 power root 3 by 2, so will be 36 root 36 over 6. So this gets cancelled. I get here 36. So A1, A4 are we found. Now we need the area of this little yellow triangle. So for this yellow triangle, we need to get the equation of A2 and A3, which turns out to be the chord of contact of ellipse. So A1, A3 is nothing but the chord of contact of ellipse. So for the chord of contact of ellipse, we have here x1 by a square. A square is 6 and 3. Okay. 6 plus y1 over 3 is equal to 1. So since x1 comma 0 is minus x1 comma y1 is minus 3 comma 0, we can just plug in here. So x into minus 3 over 6 is equal to 1, but this is 0. So this gets cancelled. I get here x is equal to minus 2. So x is equal to minus 2. That means the base point right here is going to be my minus 2 point. So from minus 2, I need to see where is this point intersecting on A3. So it's like this basically. This is my ellipse here, and I have this point to be minus 3 comma 0 here. Sorry, minus 2 comma 0 here. So minus 2 comma 0. So if I get to know this point, so I can find out area of this triangle. This is minus 3 comma 0. So I'll find out the area of this triangle. So let's plug it into the ellipse. So my ellipse is x square over 6 plus y square over 3, I guess. Yes, y square over 3 is equal to 1. We can plug in x is equal to 2 here. So 4 over 6 plus y square over 3 is equal to 1. That means from here I get y square over 3 is equal to 1 minus 2 over 3. So y square is equal to 1. So y is 1 comma minus 1. That means its height is only 1. So area of this triangle green is going to be, so area of green triangle would be half into base is 1 unit only from minus 2 to minus 3, and height is also 1. Uh, yeah, minus 2 to 1. So half into base into height. So this gives me half here, but and now since there are two triangles like this, so therefore it will be 2 times. So I get to see here 2 into half, which is 1. So that means from this yellow triangle, yellow is total. Okay, I'm sorry. This A1, A4R area is 36. From 36, I'll remove this green. So green is 1. So we get to see here 35. So that means option A would be true. The area of quadrilateral A1, A2, A3, A4 is 35. And also the intersect at point minus 3 comma 0. So option C is also true. So A and C are correct. Looking at this question, here we have an ellipse, and P comma Q be the point in the first quadrant, such that just let me draw this ellipse first. So I have an ellipse here, and now P comma Q be the point in the first quadrant. So we can imagine it this way. This is my point P comma Q in the first quadrant, and since this is saying outside, this is like S1 positive. So that means point P comma Q lies outside. This is S. Two tangents are drawn from S to the ellipse, of which one meets the ellipse at one end point of the minor axis, and the other meets the ellipse at point T in the fourth quadrant. Means from here, two tangents are drawn. One meets the one minor axis at endpoints of the minor axis here, one, and the second meets in the fourth quadrant here. I'm sorry, it meets. So it's a tangent. So it's like this, basically, we could say. This is my point, T. Now what it says, um, let R be the vertex of the ellipse with positive x coordinates. So that means this is going to be my vertex R. And O be the center of the ellipse. So this is O here. And now what do we need? If the area of the ellipse, area of the triangle ORT, that means ORT triangle I have to draw. So I'll just be drawing here. This is R and this is T here. So I'll connect it here. That means we want the area of this triangle. So area of this triangle is given to be 3/2, then which of the following is correct. So, okay, point O I know is 0, 0. Point R also I know. Point R is 3, 0, because that's the point with the positive x coordinate. It's the vertex of the ellipse basically with the positive x coordinate. That means the point is 3, 0. And now what else do we need? We don't have point T. So point T we can find out. So let coordinates of point T be 3 cos theta, comma 2 sine theta. So that's how we assume a point on the ellipse. Point on the ellipse is a cos theta, comma b sine theta. So a cos theta, comma b sine theta is a point on the ellipse. So here a is 3 and b is 2. Now this is my point T. So area of the triangle ORT. We know what is the area of triangle. It's basically half into the determinant of ORT. So we'll plug in here directly 0, 0. And then we have here 3, 0. And this one is 3 cos theta, comma 2 sine theta. And this area turns out to be 3/2. So we'll open the determinant with plus and minus both because we do not know what is the exact area here. This would be determined by the point T. Okay, what do we get? So from this, I'm going to have here determinant. Wait, let me open this. So I'm going to have the determinant 3 cos theta, and here this is 3 sine theta, and then 3, 0, 0, 0, 1, 1, 1 is equal to plus or minus 3. So this 2 and this 2 gets cancelled out. Now we can open it ahead, and this is going to give me simply 3 cos theta. So with this, I'm going to get here 0 determinant, and with this, I'm going to get only 3 sine theta. With 0, I'm going to get 0. So I can simply write down minus 3 times 3 sine theta. So minus 3 times 3 sine theta. And then minus 3 times 3 sine theta. Then yes, that's 0. Minus 3 into 3 sine theta. This is equal to, give me 0 minus 3 into 3 sine theta, and then this is going to be 0 and for 0. So this is going to give me plus minus 3. So I'm going to get one of them get cancelled. So that means my sine theta becomes, since this is in the 4th quadrant, that means we can be sure about the coordinates of point T. So sine theta is going to be, this is going to give me, no, this is not 3 sine theta, that's 2 sine theta. 1 minute. This is 2. Yeah, here I wrote it in insane manner, basically. This is 2 sine theta. So yes, so this is 2 here. Now we can open this. So this would give me, so minus 3 times. I have here 2 sine theta. And it would be equal to plus minus 3. So that means sine theta is equal to plus minus half. That's what we get. But now since my point T is in the 4th quadrant, so since T is in the 4th quadrant, since T is in the 4th quadrant, so this implies sine theta is going to be negative here. So sine theta is minus half. So once I have my sine theta, and then cos theta is also, cos theta is positive here. So we need to find out cos theta. So cos theta would be square root of 1 minus sine square theta. This turns out to be 1 minus 1 over 4, which is root 3 over 2. So we get cos theta. That means now I have the point T. So point T is going to be 3 times 3 cos theta. So that is 3 root 3 by 2 and point, oh my God, it is so 2 sin theta. So minus 2 into 1 by 2 is minus 1. So I'm going to have here minus 1. This is my point T. Now we need to get the equation of tangent because already we have found it. So they just want the value of P and Q. So if I get the equation of tangent at point T, I can just compare it. So equation of tangent at T. The equation of tangent at T is going to be what? X into x1, which is 3 root 3 over 2 into A. A is A square is 9 into 9 plus y into y1 is minus 1 over b square. B square is 4. Okay. Is equal to 1. So now I have this point. Now what it says that this tangent passes through the point P comma Q, of course. So this tangent passes through P comma Q. This tangent passes through P comma Q. So if this tangent passes through P comma Q, that means it should satisfy that point. That means point P comma Q should satisfy the equation of this tangent. So I can just simply write down here P and Q. I can simply write down point P and point Q here. So once I plug in here P and Q, now what it requires is I can cancel 3 and 3 here, and I'll be having P root 3 over 6. And then this is going to be minus Q over 4 turns out to be 1. So now I can directly look at the options and see which option is correct. So P turns out to be, P is here, Q is 2, P is 3 root 3. Let's go for this option. So option A, if I check, then Q is 2 here. Let's plug in Q is equal to 2 over 4 and P is 3 root 3. So 3 root 3 into root 3 will give me 3 root 3 into root 3 over 6. So this gives me 1 minus Q is 2 over 4. So 2 over 4 will give me half, and this is 3 into 3, 9 over 6. 9 over 6 is 3 by 2 minus 1 by 2 is equal to 1. So yes, that means we directly get our option A correct. Looking at this question, so here you're given an ellipse. Let E be the ellipse for any 3 distinct points P, Q, Q dash on E. Let M, P, Q be the midpoint of the line segment joining P and Q, and M, P, Q dash be the midpoint of the line segment joining P and Q dash. Okay, so we're going to have an ellipse here. So it is this way. Here comes the major axis. So now they are saying that for any 3 distinct point P, Q, and Q dash. So say this is my point P, and say this is Q, say this is Q dash. Okay, M, P, Q be the midpoint of the line segment joining P and Q. So if I join this here, the midpoint here is going to be M. I'll say here this is M1 in fact, because they have given both the midpoints are same MM. One of them is the midpoint of Q, and one of them is the midpoint here for Q dash. So this is going to be basically M2. So this is the midpoint. Now, if I consider joining these two, because the midpoint, then the maximum possible value of the distance between MPQ. Okay, MPQ is nothing but M1, and MPQ dash is nothing but M2. So they want the maximum possible distance between these two, M1 and M2. So we want the max of M1, M2 we want. So we can solve this question by the way, the basic property of class 10, in fact. So if you consider then M1, M2, so what we know is line in triangle P, Q, Q dash. We know that M1, M2 is parallel to Q, Q dash, because if we join the lines midpoint of these two sides, then it's going to be parallel to the third side, and also it's going to be half of it. So M1, M2 is going to be half of QQ dash. So now that means if I my M1, M2 is directly proportional to QQ dash. So if QQ dash is maximum, then my M1, M2 is maximum. So max of QQ dash is so max of Q and Q dash. That means if I take this any 2 points here, Q. So I could have taken Q and Q here. So I can take this one also. I can take this to be Q and Q, Q dash. I can have this one here. Or if I join any other point, let's say I can have Q and Q dash here also. Since we want the maximum, so maximum I'm going to get here when I choose the endpoints of major axis. So max of QQ is nothing but the major axis. That's the only possibility. Otherwise, no one is going to be maximum. So major axis is going to be what here? It's this point is 16. So this is 4, comma 0. This is minus 4, comma 0. So major axis is 8. So therefore, maximum of M1, M2 is going to be half of QQ dash, which is 8. So this is going to be 4. So the correct answer would be 4.